Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I'll look forward to seeing you inside the video.
Okay, this is the final video in the playlist where we're looking at November 2019 and it's paper 3 higher for Edexcel. In the previous video we completed through to question number 18. In this video we're going to start at question number 19. Okay, so here we are in question number 19 and we've got a graph showing information about part of a cyclist's journey and it's plotting distance travelled against the time in seconds, and the question is asking us to work out an estimate for the speed of the cyclist at time 6 seconds. So the easiest way to do this is actually to draw a tangent against this particular curve. Now the reason we do that is because speed is really change in distance divided by change in time. Now this is going to be perhaps different for everybody, but it will give you a little bit of an idea about how we can do these sorts of things. So if I just draw this triangle along here, it's going to allow me to calculate a time change of 2 seconds and a distance change of a little bit more than that. Okay, so let's have a look at the formula. So if we write the formula, and I'm just going to write at the bottom here that speed equals, now if I just put delta distance, it just means change in distance divided by delta time. It just makes my thinking just a little bit easier. Bear in mind these are higher level questions, so they are a little bit trickier to deal with. So we're looking at the distance change between this point and this point, which is the difference between 16.5 and 3.5. Okay, so if we look at that, we've got 16.5, take away 3.5, and then the difference in time is going to be the difference between 4 and 8. So that's actually going to be 4 seconds. And when I put that into a calculator, I'm going to get 3.25, which is the answer to the question, 3.25 meters per second. Okay, hopefully that's okay for you. Let's move on then to question number 20. So in question number 20 we've got an arithmetic, no we haven't, we've got a quadratic sequence. That's a little bit different because the way in which we do this is we look at the difference, at least the first difference, and then we look at the second difference. So if I look at the first difference first, I've got a difference in this particular case of 1, then 3, then 5, and then 7, but the second difference is actually 2. That allows me then to use 3 different formulas, because what I'm looking to achieve is a quadratic sequence which has got an squared plus bn plus c. So the values I'm looking for is a, b and c, and what I know is that this first value is 2a. So therefore a in this particular case, if 2a equals 2, then a must equal 1. So therefore this value is going to be 1. Okay, let's look then at the second formula that I need to remember, which is 3a plus b. So therefore I've got 3a plus b equals 1, and I can just substitute my value of a, which I've just worked out, which was 1 as well. So therefore b in this particular case is going to equal to minus 2. So therefore b is going to be minus 2. And then my final one is a plus b plus c equals minus 1. So therefore I can just use this, a plus b plus c equals minus 1. I've got my value of a as 1, my value of b is minus 2, plus c equals minus 1. So therefore minus 1 plus c equals minus 1. So in this particular case c equals 0. So I can write that at the very top, 0. Okay, so I'm in a position now where I can just tidy this up. I've got 1n squared minus 2n So therefore I'm just going to write my quadratic sequence as n squared minus 2n, and that would be the answer to the question. There are a couple of different ways in which you can do this particular question, as there is with quite a lot of questions that we do. However, if you're not sure about what I've done there, let me know in the comments and I can always send you towards a playlist. Okay, let's have a look at question number 21. A bias coin is thrown 4 times. Probability of getting 4 heads is that. So the probability of getting 1 heads in one throw. So probability of getting a head in one throw is actually going to be the 4th root of 16 over 81. Okay, so that very handily works out as 2/3. This is a calculator paper, so you can just plug that directly into your calculator. So therefore, the probability of getting 1 head on one throw is going to be 2/3, which therefore means the probability of tails on one throw is going to be equal to 1/3. Okay, so therefore the probability of getting 4 tails in a row, if I just put probability of getting 4 tails, well, you can write that as 1/3 to the power of 4 if you want, or you can just say it's 1/3 in the first throw, 1/3 in the second throw, 1/3 in the third throw, and 1/3 in the fourth throw, which is going to give us a final answer of 1 over 81, and that would be the answer to that particular question. Okay, hopefully that's all right for you, and again, let me know in the comments. Okay, so question number 22. This is one of those where it just takes a little bit of working through. It's actually not too bad. We can say this is 7x minus 14 at the top there, and at the bottom what I'm going to do is factorise x squared plus 4x minus 12, which I'm going to factorise as x plus 6 multiplied by x minus 2, and that would be fine for the first fraction. The second fraction, now you'll spot that it is a division, so therefore what I'm going to do is multiply and flip, and while I'm at it I'm actually going to factorise the denominator as it is here, but now as the numerator for the value of x. That's going to give me x squared minus 36. Now what's going through my mind is actually that is the difference of 2 squares, and we'll come to that in the next line. Okay, so let's just move a little bit further with this. I'm going to factorise the top for 7, and I'm going to get x minus 2 divided by x plus 6 multiplied by x minus 2. So that's good because those minus 2 x's or x minus 2 can also be cancelled out. And then I've got multiplied. I mentioned before it's the difference of 2 squares. What I mean by that is that's going to be x plus 6 multiplied by x minus 6, all divided by x minus 6. Well, that's great because I can again cancel those out, and actually the denominator of the first fraction, x plus 6, can also be cancelled out with the numerator of the second fraction. So what I end up very neatly on this particular question is the value of 7x. So therefore a is the integer 7. Okay, hopefully that's all right for you. Really good, very neat question, that particular one. Let's move on then to question number 23. Now this one is going to take a little bit of time to work through because there's quite a lot of words that go with it. Please do stop the video and have a go at each of the questions. Okay, so what we've got there is effectively a sector of a circle which has now been made into a cone. Okay, now what it tells you is that the cone has a volume of that and a height of 3.6. Well, that's really useful information because what I'm going to do is I'm going to use that information to figure out the radius of the cone. Okay, because I can use the formula that's actually given to us right at the very top here, which is volume of cone equals 1/3 pi r squared h. Okay, so without doing too much and reading through too much, what I know is that the volume equals 1/3 pi r squared h, and I'm told that the volume is 56.8. I'm also told that the height of the cone is 3.6, so therefore it allows me to use my calculator, and eventually I should get to the point where I got r squared equals 56.8, and that's going to be divided by 1.2 pi. Okay, again, pop that into a calculator and I'm going to get 3.88158 is equal to r. Now that is actually the radius of the cone. Okay, so let's go back to our drawing, and I've got then the vertical height, which I know to be 3.6, and I've just calculated the radius of the cone as 3.88158. Well, guess what? Now it allows me then to use Pythagoras to figure out this length here. Okay, now the reason I want this length here is because it's exactly the same as the radius of the sector. Okay, so it's a little bit difficult maybe to imagine, but if you take that sector and make it into the cone, then AO is actually going to be the side of the cone. So therefore we can use Pythagoras. If I just put a point here, so use Pythagoras. Okay, and what we're going to say is that L squared equals, I'll just write it out, 3.88158 squared plus 3.6 squared, and again work all of that out, and you're going to get, I would just do L is equal to the square root of the answer of 3.88 squared plus 3.6 squared, so therefore that's going to give me 5.294. So now, using the information I've got, I know this is 5.294, which means this is 5.294. Okay, so we're in a position now where we can actually work out the area of the cone as well, because the area of the cone will be the same as the area of the sector, and we need that bit of information to be able to answer the question. So therefore the next little bit is going to be surface area of cone. So surface area of cone is going to be equal to, and again the formula is right at the top of the page, pi RL. Okay, so I got pi multiplied by 3.88158, which is the radius, multiplied by the length that we've just found out, which is going to be 5.294. And when I get all of that together, what I get is 64.557. If you want, centimetres squared, which is actually the area of the surface area of the cone and the surface area of the sector. So now finally we've got a couple of things that we can use in order to work out the angle that we're looking for, because don't forget that while it has the same area, I can use pi r squared as if it's a full circle. You'll see what I mean. So what I can say is that angle AOB, which is what I'm looking for, out of 360 is equal to pi multiplied by the radius squared, because the area of a circle is radius pi r squared, 294 squared. Okay, and that is going to be equal to the area that we've just worked out, which is 64.557. So this is the key bit of information that we need, and by manipulating all of that, again using your calculator, and there is actually another page on the exam for you to carry on working, but I'm going to try my best to keep it on this one page if I can. Okay, so what I'm going to end up with is angle AOB, which is what I'm looking for, out of 360 is going to equal to 0.73326, and if I multiply then across by 360, I finally get the angle AOB, which is the answer to the question, is going to equal to 200 163.95 degrees, or 264 degrees, and that's to 3 significant figures. So really quite a lot of work there that's been sort of condensed into 1/2 page. Okay, you do get the full page for the rest of the question to actually work on, and I do appreciate I've skipped through a few steps there, but hopefully you get the idea. Okay, let's move on then to the very final question on this particular exam, which is a question on vectors. Now, a little bit trickier, I guess. You know, the ends of these questions do tend to be a little bit difficult, but let's have a look. So OX is going to be vector A, so I'm just going to put A in brackets there, and OY is going to be vector B, and what it tells us is that P is a point on OX such that OP to PX is 1 to 2. So what we basically means this is 1/3 of the way, and this is 2/3 of the way. Okay, and it's the same with R on point OY, and that's going to be 1/4 of the way and 3/4 of the way. So now we've got enough information to be able to start looking at the different kind of bits of vectors that we need for this. Okay, so the first thing I'm going to do is I'm going to work out vector XY, because I think that might be quite helpful to me. So let's just move this up. Now vector XY, okay, is going to be equal to, and what I always suggest with these is that you write the pathway that you're looking at. So in this particular case, I don't know anything about XY, but what I do know is I can go from X to O, which is going to be minus A, and then from O to Y, which is going to be plus B. So therefore I can write that as minus A plus B, or much preferred is B minus A. Okay, so therefore I know that XY is B minus A, which is going to be this here, B minus A. Okay, however, because it's a parallelogram, I also know then that OZ is going to be B minus A, and that's an important thing. So if I just put therefore vector OZ is also equal to B minus A. Alright, so therefore it allows me now to start looking at the ratios that we're interested in, which is ZP and ZR. So let's look at ZP first. Now ZP, well, I've got to go from Z to O, that's okay, I know that, and I've got to go from O to P, that's okay, I know that. So I can write that down as a pathway. Now you might want to sort of stop the video and have a look at the question, maybe do a kind of a sketch of the question if you wanted to, and that will give you a little bit of an idea of how I'm following this through. So ZO is not OZ, it's the negative value of OZ, so I'm going to write it as minus brackets B minus A, and then OP, well, I know that OY, OX is going to be A. If I just go back up to the screen there, OX is going to be A, therefore OP is going to be 1/3 of A. Okay, so that's 1/3 of A, and I need to just tidy this up. I'm going to get minus B, and then I'm going to get plus A, because it's minus times B, and then minus times a minus is going to be positive, and then plus 1/3 of A. Again, tidy all of that up, and I get this, what seems like quite a difficult 4/3 of A minus B. So now finally I've got ZP. That's great. Okay, let's have a look now at ZR. So if I just put this over to the other side, I'm going to get ZR. Okay, well, ZR is not too bad. I can go whichever way I like, really. What I'm going to do is I'm going to do ZO again, and then I'm going to do OR. And that seems fine to me. So again, that journey would be ZO again, and then plus, in this particular case now, OR. Well, ZO we've already worked out. We know that's minus B minus A. Okay, and that's going to be now, OR is going to be 1/4 of B, and again I just need to tidy this up really, so I'm going to end up with minus B plus A plus 1/4 of B, Okay, again, tidy it up, and I get A minus 3/4 of B. So now finally, I've got vector ZR, and over before I've got vector ZP. So these are the two bits of information I need in order to work out the ratio, which we've got there, ZP to ZR. Okay, so this is going to be a little bit trickier, but hopefully you'll see that what I can do is, if I look at ZR, I can factorize ZR by 3/4. Now the reason I'm going to do that is, you'll see hopefully in a minute. So therefore I can say ZR is going to equal to 3/4 multiplied by, now what do I multiply A by, or 3/4 of A by, to get a full value of A, or 1A? Well, I multiply it by 4/3A. Okay, so hopefully that, so 3/4 times 4/3 is going to give me 1, and that's what I'm looking for, as a value of A, 1A. Okay, and then I've got minus B, so I don't need to do anything with B now. But what you'll see then is I've got a common vector, or a common factor, which is 4/3A minus B and 4/3A minus B. So therefore I can say that the value of ZR is 3/4 of the value of ZP. So what we've actually got, what I'm going to do is I'm actually going to draw this down as if it's from the sketch at the very top. So I've got Z, and then about there I've got R, and then I've got P at the bottom here. So what we're saying is the whole vector is going to be 4/3A minus B. But however, ZR is 3/4 of it, and RP is going to be 1/4 of it. Okay, so therefore, if I'm looking for the ratio ZP to ZR, which is going back to the original question, it's going to be 4 parts are going to be ZP, that's the overall value, okay, and then it's going to be 3 parts which are ZR, so therefore the answer will be 4/3, and that would be the answer to this particular question. I'll just go back and put that working on the screen for you. Okay, I hope that's been helpful, and I'll look forward to seeing you inside the next video.